Okay, so welcome back, everybody, and we're going to talk about documentation of modules now, which is very important. You might not think it's important, but it is, right? It's good for your understanding and readability of your code, and also for somebody else who's coming behind you inspecting your code and wondering what does this module do, right? Um, it's there to help guide other users as well, as well as yourself, because sometimes you may write code and you understand how it works in the moment, but when you come back to it, say a week later or later, you have no clue what's going on, right? Okay, so we want to understand doc strings. You saw me use a doc string. Let's see, it was here. Here's a doc string. It's three quotation marks, right? That's a doc string. What's going on here? Okay. Um, just some updates here. Okay, so make the connection between well-written documentation and unit testing. So each function in a module or program needs to have a document string or doc string. Uh, so in PEP 257 is Python enhancement proposal number 257 as found on python.org defines a document string as the following. A doc string is a string literal that occurs as the first statement in a module, function, class, or method definition. Such a doc string becomes the uh, underscore doc underscore special attribute of that object. So it's so all the doc strings you write are stored in this variable. So doc strings for functions. So all modules should normally have doc strings, and all functions and classes exported by a module should also have doc strings. Public methods should also have doc strings, including the underscore underscore in init underscore constructor. We'll find out more about this. So for consistency, always use triple double quotes around doc strings. So here's an example. We are going to focus on description, arguments, and returns. So here, here is a function we have called square root, and it takes a input. It takes a parameter n. So this is how we would break up. This is how we would organize a doc string. So notice here my doc string didn't really it doesn't really follow that format, right? I just wrote in some arbitrary stuff there. But here we want to have a description of what this thing does, what this function does. We want to know the arguments that it takes and what it represents, and then we also want to know what it returns. So here's the beginning of the doc string, and then here's the end. So everything inside here pertains to the doc string. Okay. So the description: determine the square root of a number. So that's what this function does. Then we have args or arguments, and then we say n is a floating number, and the number to use in a calculation the assumption is that n is greater or equal to 0, and then what it returns is it returns back a float, and that float is the square root of the number n. Okay, and then here is the actual function execution. Here we just actually just use math.square root. So pre and post conditions. So precondition um, is here. So precondition is pretty much like on the input. We want to make sure that the input we're giving is greater than or equal to 0. That's a precondition because that needs to be true before we even run the function. The post condition is that we should return the square root of that number. So pre and post conditions. So the precondition statement indicates what must be true before the function is called. The postcondition statement indicates what will be true when the function finishes its work. The precondition and postcondition together constitute the contract of the function. It's knowing these two conditions that allows you to treat a function as a black box. So, what does that mean to treat a function as a black box? Meaning that we don't need to understand the ins and outs of the function. All we need to know is that what is the precondition? So, what do we need to ensure as a user? And then the postcondition is what the function will produce or what it guarantees as long as that precondition is correct. So those are the only things we need to know. We don't need to understand what each line inside the function does. We just need to know what do I need to pass the function? Okay, once I pass this to the function will give me this. So that's what this statement means. It is knowing these two conditions that allows you to treat a function as a black box. Black box meaning you can't see inside. So in general, precondition. The programmer who calls a function ensures that the precondition is valid. The programmer who writes a function can rely on the precondition being true when the function begins execution. Postcondition. The programmer who writes a function ensures that the postcondition is true when the function stops executing. So here's another example. So we have a function called getOption. So we have a doc string. So here's the description. Ask user for a valid option. Only integer values between 1 and n are accepted. Loop until user enters a valid option. So what is a valid option? Okay. In an arguments, n, and n is an int, the number of options that the user has to choose from. So n represents the number of options that the user has to choose from, and an n has to be greater than or equal to 1. So there has to be at least one option. And then it returns option, and it returns the option, which is an int. So the option number that the user chooses. So then here is the actual function body. So we have a variable called asking, which equals true. So while asking is true, try option equals. So we want to get the input from the user as an int. And we want to see if that number is in the range of between 1 and n plus 1, then they did what we asked. So we don't want to keep looping, so we change asking to false. Else print need to enter a value between 1 and n to continue. And then we write the same same thing for the accept block. And then we return that option. So that's exactly what the post condition says. The option number that the user chooses. So we're just gonna literally just return back the number that the user chose. So testing implications. When developing test cases, we need to know the contract for the function. Without knowing this contract, it is not possible to develop appropriate and thorough test cases. So what does that mean? So without knowing how can I test a function if I don't know what the acceptable inputs are and what the output is supposed to be based on that input? So until I know that contract, I can't properly test that function. So consider a function for the number of diagonals in a polygon. So here's just the function. So are negative values of n allowed? What about n equals 0, 1, or 2? Well, you can't have a polygon with 0. It depends. Like, what does n even represent? Does it represent a number of sides? Right. Um, so should our function take care of this? What should we test? Right. So that's a question. Should we validate the input inside the function, or should we expect the user to put in the number, the correct number? So should they be responsible for it? And what should we test? Okay, so with a doc string, we get some more clarity. So we get a description. Determine the number of diagonals in an n-sided polygon. So n represents the sides. Therefore, we can't have a polygon with 0 sides, or 1 side, or 2 sides, right? We can have one with 3 sides. Okay, so n represents the number of is an int that represents the number of sides of the polygon, and the assumption is n greater than 2. So that's the precondition. And the post condition is that we will return the number of diagonals associated with um, that polygon, and that number will be an int. So now that we have this contract, what would be the appropriate test cases for this function? So now you got to think. So appropriate test cases would be any number greater than 2, right? So your turn. Mathutilities.py. Add appropriate doc strings to all the functions in this module. Update the tests for your module to now match your documentation. So now you should practice making your own doc strings, right? And this is something that for this unit 2, that will be asked of you for the summative assignments. Okay? All right, so let's stop there, and I'll see you guys in the next one.